we're doing is solving systems by graphing. I put the handouts in the back. You have the worksheet. You have the notes. Okay, notes are part of your assignment. On page 383, you want to write out the definitions of these two words. Okay? So basically what we're doing here is we have two linear equations. Okay? And we have an ordered pair. Notice these aren't in slope form, correct? We're not concerned about that if we're given an ordered pair. And I'll explain that more as we get further along. So we have two functions that we're going to do substitution for. Okay? We have 3 steps in this problem. The very first step is easy. We're taking these two equations and we're writing them side by side. Is that clear? Then from there, step 2, we're going to do substitution. Okay, so we're going to take this ordered pair. What comes first in an ordered pair? X. Y is second. Notice I color-coded these. Okay, so you know which one's the X and which one's the Y and where it goes. Okay, so we're looking at this right here. We're going to place this X with 4. We're going to replace this Y with 1. Now notice, if we have a number next to a variable, what type of math is that? What type of math is this right here? 2y, 3x.
Multiplication.
Multiplication, yes. So when you go to insert these, make sure that you put them in parentheses, okay? From here, then we're going to solve, we're going to do order of operations. 2 times 1 is 2, bring down the 4. 4 plus 2 is 6, 6 equals 6. So what we're trying to do is we're trying to prove this equation as being true, okay? Now we're going to do the next one. We're going to plug in the 4, we're going to plug in the y, and we're going to solve for it. 4 minus 1 is 3, 3 equals 3. Both of these solve. Both of these are true statements. They can't be minus or anything like that. That'd be identical. Can 7 be equal to 3? No. It has to be the same exact number. So as long as these two equations check out from plugging in this order pair, then we have one of our vocab words. Both the equations are true because it's a system of solution. Okay? That means this ordered pair works within these linear functions. We're okay. Okay? Let's go through this one. Another one. We have an x, y, negative 1 and 2. We have two functions. Not linear. We're not concerned about that. Not till we get over here. So first step, I write them side by side. And then I enter in my x and y. So negative 1 for x, I'm plugging in here. Y for 2, 2. Then on this side, x, negative 1. And then y for 2. Notice all my inserts are in parentheses. Do we see that? From here, order of operations. 2 times negative 1, negative 2. 5 times 2 is 10. Bring down the 8. Solve. Negative 2 plus 10, 8. 8 equals 8. This one's okay. Next one. 3 times 1, negative 3. Negative 2 times 2, negative 4. Adding negative 4 and negative 3, negative 7. Oh, this doesn't work. So we don't have a solution here. This ordered pair will not work. It has to work in both of them for it to be a system of solution. Are we clear? Okay. Next one. We don't have an ordered pair. This is where graphing comes involved. Okay? So we're focused on y equals mx plus b. Okay? We're going to graph these. Are these in slope form? Can we graph these out? We have a b, right? We have a rise and run, so we can. So this first one, we're going to start in negative 3, and we're going to go up 1 and over 1. Can someone tell me why we go up 1 over 1?
Because x.
And x has a value of at least what?
1.
Yes. There's always an imaginary 1 in there. And if it's a whole number, we have to drop a 1 underneath there. We always have to have a run of 1. Always. Okay? So, negative 3, up 1 over 1, up 1 over 1. This is our first line. Then we're going to go graph our next one. We're starting at negative 1. So negative 1, and we're going down 1 over 1. Down 1 over 1. We form the line. So there's our two lines. Now, what's crucial here, we're looking at where these lines connect. Okay? So my x is 1 and my y is 2. So I'm going to use that ordered pair. X is 1, y is negative 2. Is everyone following me so far? So we graphed these out. We found this ordered pair. Now we're going to take this ordered pair and we're going to do the same thing right here. Okay, the same 3 steps. So, first step, we're going to write both equations side by side. Step 2, we're going to do substitution. So here's my ordered pair. It's 1 and negative 2. So I'm going to plug in the 1 for x and the negative 2 for y. Same thing over here, the x and the y. Now be careful here, this came up in your question. If you're negative on the outside of this, it's always in parentheses. Our inserts are in parentheses. The only time they're not, if it's on this side and it's equal. There's no reason to put that in parentheses. You could if you're in habit of it, but understand there's nothing to do there. We just remove the parentheses and make it negative anyway. Okay, so order of operations, go ahead and solve these. 1 minus 3, negative 2, bring down the negative 2, this one's true. Negative 1 times negative 1, we want to remove the parentheses. Negative 1 plus negative 1, negative 2, which is equal to negative 2, this checks out. So we know, finding the solution from graphing, that where they connect at the 1 and negative 2, that this makes the system solution. Are we clear? Now, your test Thursday. You're going to have 2 sets of things, okay? You're going to have ordered pairs, you're going to have 2 linear equations. When it's like this, you're not worried about graphing, right? You can solve, okay? But you have 3 steps. Looking at this one, we don't have an ordered pair. You have to find the ordered pair. But in the test, I just don't want you to find the ordered pair. I want you to go through the 3 steps, okay? Write them side by side, do the substitution, and solve for them. Is that clear? Okay, one more. We have an ordered pair of 2 and 3. Now look, these are linear, aren't they? So we have both going on here. So the first thing we're going to do is graph this. Then we're going to plug it in and solve for it. So negative 1, we're starting on the graph. We're going to go up 2 over 1. That's my rise and run. And then I'm starting at 5. I'm going down 1 over 1 because of negative x. So those form my 2 lines. Okay, I label my 2 lines. Now I'm looking at for where this connects up. So my x is 2 and my y is 3. So my order pair is 2 and 3. I already know it works, right? Before plugging it in. Well, let's go through the steps. We're going to write the 2 linear functions side by side, and we're going to enter in our x and y. So our x is 2 and our y is 3. We're going to plug it in, follow order of operations. So 2 times 2 is 4. Bring down the negative 1. We have to multiply first before adding and subtracting. We're going to subtract 1 from the 4, 3. And then 3 equals 3. This one's okay. Then the other side, our 3 is y, our x is 2. In parentheses, makes this a negative 2. This is plus 5, negative 2, which is 3. 3 equals 3. Both of these equations check out. This is a system solution. Any questions? So this one's all of it, right? Ordered pair, 2 functions. We have to enter it to graph it out. We follow the 3 steps to solve. You have this right here. You have an ordered pair. You're plugging it in. You're not concerned they're linear. Now let me tell you where this is going to go as of Friday. Friday, after your test or whatnot, you're going to have some equations right here that are not linear. Okay? So you're going to have a problem like this that you're going to have to get into y equals mx plus b before you solve it. Okay? Because you have to graph those out to find that ordered pair before you can plug it in and follow the 3 steps. Is that clear? We'll practice that a little bit. So what we just went through, that's what you're doing now is today, right? You're gonna go in, you're gonna solve these 3 by plugging in the ordered pair, you're gonna follow all 3 steps. These 2 you have to graph out to find what that point is, then follow the 3 steps to solve it, okay? You want to turn this in today. This is giving you practice for the formative on Thursday, okay? Roman, you good? Everyone's good? Do I need to go through it one more time? Not too difficult, right? Okay, good.